That we're up and running. Welcome to my session, AppV, implementing AppV, lessons learned from a production rollout. My name is Men van der Plas. I come from the Netherlands, a little country in Europe. I work for a company called Login Consultants, which is an international consultancy company, an independent, vendor-independent consultancy company. I'm an AppV MVP for a couple of years now, since 2009. And I do some blogging on softwareblog.com. So by raising hands, can you tell me how many of you have knowledge of AppV5? Not that much? How about AppV4.6? Okay, so it's around 30, 40%. So this session will be about AppV5, but I cannot talk about all the differences in AppV5 at once. So some familiarity with some of the technical concepts of AppV is preferred. So try to catch up, and otherwise, if you have any questions, just raise your hands or walk up to the mic or meet me outside of the session. So goals for this session is to give you an overview of the relevant changes in AppV5. As I said, I cannot go through all of them, but I've picked some of the stuff out that's the really important ones. And as I've been implementing AppV5 with a customer, I want to walk you through the design process that we did there and share some of the implementation pitfalls and gotchas that we ran into. So let's start by looking at the changes in AppV5. How many of you have done anything with it, like a pre-production pilot or... Okay, some of you have looked at it. Okay, excellent. As you may have noticed, there are a lot of changes in AppV5 compared to 4.6. It's basically built from the ground up, and all the things that we are familiar with have either changed or disappeared, and new things have evolved in there. Some of the items are mentioned here, like there's no Q drive anymore, there's no 4 GB limit. We have a more open structure to store our delta settings of the user, which was originally in a lockdown PKG file. We have rich PowerShell scripting, web-based management, just to sum up some of the changes that are part of AppV5. But the bottom ones, I think, are the most interesting ones because they actually extend the product even further compared to AppV4.6. So we have something called extension points now, which can actually integrate more tightly into the operating system. We have connection groups as a follow-up of dynamic suiting, where we can centrally manage inter-application communication. We have a shared content store specifically for hosted desktop environments. And we have deployment and user configuration, which are comparable to earlier OSD implementation. But before I dive into that, let me quickly show you how the AppV client works and how that handles virtual applications. So I have a client here, which is equipped with the AppV5 client, as well as the AppV4 client, which is why I have a Q drive on here. Oh, I'm sorry. There will be a tech guy looking at this. Just to continue, you can see that, for example, the place where the applications are stored on the file system are no longer locked down, but they're actually part of program data AppV, which is just an open file system. You can browse down the folder, in this case, Adobe Reader, which is published to this machine. Let me start that one up. Oh, that's the wrong one. Push it down to my client first. Sorry for that. It's an open file structure. You can basically browse down to the... Thanks for the tech guy. Just wait for the client console to open. There it is. And in that file folder structure, you will see the applications that are part of your package. These are some high-level information, but there's also the actual files. You can actually browse down into the Q drive now, which is no longer obviously called the Q drive, and basically all the files that are part of the package are there. But more importantly, you can even start the application just like you would with a traditional local application. It's just more open. But it's still virtualized. Because if I browse down here to a folder that is part of the virtual application package, for example, program files, common files, I see a folder called Adobe here. And if I browse down to the local file system, oh, I also have a folder Adobe, but that's a local one. I'm sorry. So you can see that the, what is happening here? There it is. So you can see that there's still virtualization going on here, right? So that means also, for example, shortcuts now point to exactly the local executable that is part of your AppV package now, and no longer like a launching process, which was part of AppV4.6, the SFT tray. But it also means that if you want to do like customization, getting inside the virtual environment, there are different ways to do that now. I'll explain some of those a little later. So let me walk through a couple of those new extended features. Let's start with virtual application extensions. So in AppV4.6, you would have like shortcuts and file type associations where you could, start the application from. That was the interaction point of the user. That's now extended. You can also include now URL protocols, for example, Mail2 or FTP programs that can launch virtual applications. We can set default program behavior, so I can actually register an application to become the default program in AppV5, and all kinds of stuff. So that actually will extend the applicability of some of those virtual applications onto the operating system. If we look at deployment and user configuration, it's basically the new version of what we were used to doing in OSD scripting, in OSD files. We could edit the OSD files to do some customization outside of the packaging process, so you don't have to go back to the sequencer. That's now replaced with deployment and user configuration. Every package is delivered with a deployment and a user configuration file. You can copy those out and you can edit them. They're basically XML. And they are implemented at either publishing time or registration time of the AppV client. And there's a section in there for both user configuration as well as machine configuration. And especially the machine configuration is an interesting one because you can leverage, for example, the system account to make actual changes onto the operating system. So I could actually install like a pre-required software from within the AppV package. So that's a pretty neat thing. I will demo that a little bit later. From a high-level perspective, the same things are basically possible. So you can add registry tags, you can add script tags, you can customize shortcuts, file types, just like you're used to in the OSD file format. But this file format is totally different. It's still XML, but the structure is totally different. And they also work in a hierarchy. So part of the package is the manifest.xml, and on top of that, the deployment XML is applied, and on top of that, the user XML is applied. And that's the hierarchy in which it works. So connection groups are actually the new version of Dynamic Suite Composition. How many of you are using Dynamic Suite Composition? Not that many. Sort of, maybe. Challenge with Dynamic Suite Composition I always found was that it was hard to manage, right? You register the application or you register the dependency of the application within that application package, within this very specific file of that application package. So once you have like 100 applications deployed, you had no idea on which applications were tied to which ones. So if you have to update one, you have to find out how that is linked to other applications. I mean, you could script it, but it was still hard. So in AppV5, communication between virtual applications are no longer managed at package level, but is either implemented in the infrastructure, so the AppV infrastructure or the SCCM infrastructure, or it's implemented at the AppV client. So you can actually manage them centrally. Important is that they hold their own identity, which means that if I have an application with a certain set of configuration and I have another application with another set of configuration and I create a connection group between them, the connection group itself holds a third set of configuration. which is not the same as the other two. So the settings are actually saved separately from the main applications. And you can also set separate permissions. If you are bundling virtual applications together, there are different kinds of conflicts that can occur. Either the application or both applications hold, for example, the same file or the same registry key, and by prioritizing the connection group, or actually setting the order in the connection group, you can set which application will win. It's a kind of theoretical conflict because, I mean, the applications, they have some kind of relationship, so it's not very likely that it's conflicting in a bad way. It's basically, you know, maybe some files got caught up in the sequencer. And if a connection group, so let's say I have an application that is part of two connection groups, I can manage that one as well by setting priorities in the connection group of XML as well. So I can make sure that if I start that application, I know in which virtual environment it will run in. And the fourth one I like pretty much is something called the shared content store. So this was in AppV4.6, this was the read-only shared cache, I think it was called. How many of you use that in VDI deployments? 1, 2, 3, 4, 5, some of you? So the challenge here with AppV4.6 was that it was like you had to create this read-only file, copy it out to a central location, point all your machines towards it. If you had to update it, you had to copy it back out, create a writable copy, put it back in, the file was locked, and you had to update all the machines. It was kind of hard to manage. The shared content store in AppV5 works totally different. It's basically one setting that you set on the AppV client, and what it does after that, it will never stream any application down to the client beyond that point. So it will download the information that it needs for like publishing, shortcuts, icon files, and those kind of things. And after that, all the binaries it needs, it will always redirect back to the streaming server or the file server or whatever you're using. So the cache will never be, or the application will never be part of the cache. Now, obviously, I created network dependency, both in a performance way as well as in a connection way. But if you look at VDI scenarios, for example, if you do a stateless VDI scenario, the chances are that a lot of those applications end up on the same machine, on the same host, the virtual machine. So you can save up a whole lot of storage. So to give you an example, at this customer we had a package store that was 12 gigabytes, which was about 50 applications. And the hit on an individual VDI was only 580 megs. So that's like 95% storage reduction per client alone. So that can give you a very interesting case if you look like to calculate the cost of that VDI or that hard storage platform. So let me give you a demo. Hopefully it will not be pink again. It is pink again. Mr. Tech Guy, can you do your trick again? So let me start by doing a connection group demo. I have 3 applications here, which are plugins to Internet Explorer. And I'm going to add and publish them to this AppV client. This is pretty basic stuff. One application in use. I don't know which one that is. This is basically, we could do this with AppV4.6 as well, right? We could sequence a plugin, create a shortcut to Internet Explorer, pull the plugin pull the Internet Explorer inside the virtual environment, and basically launch it. It's basically what AppV can do as well. AppV5 can do as well. So I started this application, and I have the virtual applications, or the plugin is now part of the Internet Explorer. But what I can do now with connection groups, I can actually make a connection group on the client. So I did not sequence, or I did not build the relationship of the application packages at the sequencing time. I'm doing it at runtime at the client now. But you can do this in your infrastructure as well. So I'm creating 2 connection groups. I'm creating connection groups which ties Adobe Flash to JRE, and I'm creating a connection group that ties Shockwave to Flash. So now it's implemented. And if I start Adobe Internet Explorer with Flash, I can see that I have both the Shockwave Flash object as well as the JRA plugin. So the applications are now bundled together in the same virtual environment and tied to Internet Explorer. And the same thing happens if I start the Shockwave player. But the interesting one is that the JRA is part of two connection groups. So the AppV client has to decide in which virtual environment you want it to run into. And that's basically how you work with priorities, which are part of your connection group XML. Lowest priority wins. So that means that if I start JRA, it's supposed to run up in the Flash connection group and not in the Shockwave connection group. Let's see if that also works. So this is how you handle priorities in connection groups in AppV5. But as I mentioned in the introduction, the AppV5 does not have a launcher object anymore, which means that the shortcuts that I'm running are basically pointing directly to Internet Explorer. You can basically run for any local application with a switch and run it inside the virtual environment. So the actual shortcut to Internet Explorer does not even have to be part of your package. And the integration goes even further because, like in AppV4.6, I now still have a specific shortcut that I have to run this particular plugin. But I can also tell Internet Explorer to always run in a certain virtual environment. And I can do that by leveraging the run virtual registry key. The run virtual registry key is part of the, let me take this one for example. It's part of the software Microsoft AppV client registry. And I can basically put any process in here and tell it, by changing the default value, to run always in this virtual environment. So if I apply this to this machine, I used to start this specific shortcut, right? But I also have like the default shortcut to Internet Explorer, which is not altered by AppV in any way. So if I run this Internet Explorer, I can see that it now always will run inside the virtual environment of the plugins. That's pretty cool, right? What they did. I like this one very much. So this works for both connection groups as well as virtual applications directly. But you can only register one virtual environment, obviously, or a connection group per process. So it's not there yet, but this is actually a good way to do this. So let me give you another example of how you can add a virtual application package which requires a dependency. I have an application that needs a PDF printer to be installed. And I've made a script that actually installs the PDF printer when the application is added to the AppV client environment. Now remember, I'm actually installing stuff, so you have to be careful still, again, like your legacy applications, look for conflicts and those kind of things. If I add and publish this application, let me show you the add remove programs. I have no specific software installed here other than the AppV client and some pre-requirements. I'm now going to add the virtual application to this environment. And you can see that I've now installed the Primo PDF software locally into Windows. So this is pretty neat. You can now actually tie your virtual application to a specific piece of information. Now, we're amongst AppV guys here, so don't tell the SCCM admin that we can do this now, right? We have this specific infrastructure, and they're not afraid of us because, you know, it's just this virtualized software. This cannot change the system. Well, in AppV5 we can. But we don't have to leave our stuff lying around. So if I remove the package, there's actually removal scripts, part of the package, where I can neatly remove the Primo PDF printer again when the application package is removed from the system. So this is pretty nice stuff. Like I told you, the configuration files, the deployment configuration and user configuration files are very similar to what you can do with OSD files and scripting. So for example, I have a XML file here, which I can add registry keys into the virtual environment, just like we used to do with AppV46. I can run scripts inside the virtual environment that can import registry keys. So let me show you how this works. Now remember, these configuration files are applied at different levels, at different stages. So either at adding or at publishing times or at removing or unpublishing times. So you can even extend it even further compared to AppV4. So I've now implemented the package, but the script runs at execution time. So if I launch the application, the user, doesn't even notice it. But I can run the registry editor inside this virtual environment, and I can see that it has extended the registry key right here, and also on the current user. So we can do actual scripting still and working around the application. There's one big difference compared to OSD files. Configuration files are per package. OSD files were per application. So I came into some customers, for example, that have extended scripting per application. So application within the same package, right? So application A would run script A, and application B would run script B, and both of them were in the same environment, within the same package. Since this is per package, you can only run scripts now per package, so you cannot isolate individual applications within that package. That's the only difference. And the last thing I wanted to show you is the shared content store. This client is actually set up in shared content store mode. As you can see here. So that means all the applications that I have been running were never cached on my machine, were directly streamed back from my streaming server in my demo environment. And one thing to tell if a client is in shared content store mode is by browsing down to the program data folder into the AppV and take a particular one. And you can see those gray X's in front of the actual applications. Those are only there if you have your applications, your clients set up in shared content store mode. It's basically sparse files, and they don't really live on the file system. They live somewhere on the streaming server, but the operating system is not even aware. Just all the calls are redirected back to the streaming server. So in this example, if I take the properties of this AppV folder, I would have had 426 megabytes on my AppV client if I have to run this demo in a non-shared content store mode. But now I only have 10 megabytes on my machine. So this works independently of your infrastructure. You basically set up a certain set of clients to be configured in shared content store mode, and another set of clients not to be configured in shared content store mode. And you can manage them exactly the same. There's no difference. Okay, back to the presentation. So that gives you a little overview of the changes in AppV5. But as I said, I was part of a TAP program, or an early adapter program from Microsoft for AppV5 with a customer. And we were implementing AppV5 somewhere in, I think, September or October last year. Let me talk you through the design process that we went through in implementing that environment. So the customer environment, it was a governmental company. They had about 4,000 centrally managed desktops and laptops. Majority were desktops. They had Windows XP, 32-bit, and they used traditional software deployment. They had roaming profiles, and they had two primary sites, but they were LAN connected, so there were no real network challenges. And it was also within the same city. So the things they wanted to do in their new environment, they wanted to improve the flexibility of the working locations. They want people to work in different areas of the building and not to be tied to a specific machine. They also wanted to support the diversity in end-user devices and stimulate a new way of working, like working from home or any. So they ended up with a hosted virtual desktop infrastructure, a VDI environment, right? And they were heavily betting on non-persistent VDI for the majority of their users, and they also have some persistent VDI for special applications or special users. So why did they go for AppV5? So the customer was not, as I said, an existing customer of AppV. So they were basically what was the key selling point for them was the shared content store. Because to eliminate the I/O issues that you can have in a VDI environment, they were buying these Fusion I/O cards that can, throw a gazillion IOPS at you. The downside to that is the storage capacity of those cards is limited, right? And they're quite expensive as well. So the less storage we can put on those machines, the better. So the shared content store was actually a key point why they didn't go for AppV4. But they also wanted to avoid, migration in the future. If you're not already implementing AppV, and you had to, in short terms, you had to implement it or migrate that later to an AppV5 infrastructure, you had to go through that hassle again, right? And they just wanted to adopt the latest and greatest. So their environment is not what you call a typical reference architecture. At least that's what I think. We have Hyper-V as a hypervisor in the bottom. We have Fusion I/O direct attached storage for the VDIs. So far, so good. We have Windows 7. We have ZenWorks. It was an existing ZenWorks shop. We have AppV5. We have Quest as a broker and a VDI solution. And we have Absence for personalization of the user environment. So AppV plays a pretty dominant role in this infrastructure because I was actually discussing this with one of the people in the audience that usually in these stateless VDI machines, everything that is part of your local installation, it becomes part of your image. And all the other applications have to be dynamically delivered on top through AppV5. So the challenge was, how do we integrate AppV5 into this infrastructure? I was not part of the design process and the choices they made on the other components. But I know that ZenWorks does not have any component that actually integrates with AppV5. So how are we doing this? So first we went through the documentation. Well, yeah, as I said, it was pretty early, so documentation, yeah, that was not around. So we had this, weekly calls with Microsoft helping us in the whole design process. We quickly decided to actually build an infrastructure, an AppV5 infrastructure. How many of you are AppV5 or AppV4 infrastructure customers? Okay, 10, 20%. Are the others like SCCM? Okay, that's the majority. Yeah, okay. Yeah, so SCCM was not part of this part of this stack. So we built our own infrastructure for delivering virtual applications. So the benefit of that is that it's pretty quick, right? In a VDI environment, you want the non-persistent machines to retrieve their applications quickly, and the AppV infrastructure is a very good way to do that. If you look at the components that are part of the AppV infrastructure, they're pretty much the same, but have changed in one significant way, is that there's now a separate publishing server. So to quickly run through the components, the management server is where you add the applications and manage the authorization of the applications on top of the environment. But the client no longer directly talks to the management server, which I think is a very good thing because you can create a much more scalable solution because the management server is very dependent on the management database, which in larger environments can be a challenge. So the publishing server sits now in front of the management server or in between the client and the management server, where the client talks to the publishing server and the publishing server talks to the management server, retrieving information. And it's basically a stateless machine. It has a cached copy of the information that is part of the management server, and the client talks to that. The streaming server, a very important one, because as I said, we use shared content store. And in a shared content store scenario, if you have no streaming server or your streaming server is down or your network is down, you have no applications because it's not cached in your environment. Now the VDI, they reside in the data center anyway, so that was not really a big challenge. And basically, you have two different types of information flows that go into this infrastructure. You have like management information, which flows from the database to the client to the reporting environment, and you have package data. And those two, based on those, you can, get a grasp on how to design your environment. Because package data is, megabytes to gigabytes. That's a lot of data, right? Your applications, when your applications are started, that's when the data starts flowing, whenever the application is updated, those kind of things. And it's also very dependent of user growth. Because if the number of users, if the number of applications will grow, the number of data that is part of that flow will grow. For management data, yeah, not so much. That's like XML files, small pieces of information. Sure, when you have an excessive amount of applications added to your environment, the XML files that are delivered to the client may grow, but it's neglectable compared to package data. So this is the first thing we looked at. We said, okay, this package data flow, that's a pretty important one, and the publishing server as well, because no publishing server, no applications. So the next one we looked at is something I call the package load state, because if your infrastructure is failing or is down, it doesn't necessarily mean that the applications cannot be started. I mean, in a shared content store scenario, it does. But it's also dependent on which part of the package is already actually present at the machine. And we know this from FV4. We have this feature block optimization that we can do during sequencing. But at FV5 is actually a new feature block created for that metadata that is delivered always to the client. Feature block 0 is how it's called. And there's also something new called fault streaming, where it's actually a new section in the sequencer where the sequencer behavior is different compared to FV4. And I read an interesting blog on Microsoft explaining how that works. So fault streaming basically means that the entire application will be streamed on demand. So the application is started in the most quickest way, and I'm not talking about feature blocks. It's just it starts streaming the application bits and starts it as soon as it can, and it will download the remaining blocks later. It's basically just like having everything in feature block 2. And only after the application is entirely cached, you can use it offline, and that's where you have little to no dependency to your infrastructure anymore. If you look at the impact of failing infrastructure, you would definitely see that the publishing and streaming server are your most critical components in this environment. I mean, if the management server is down, that's not very nice. You cannot add packages, you cannot change any authorization. But if you have that up and running like in 2 or 3 hours, it's fine. But if your streaming server is down, nothing can start. If your publishing server is down on a stateless VDI machine, no applications get published. So those are the most critical components in the environment. And that's why we implemented this high-level design, where we put on both locations a single management server. So no, we didn't feel like creating any high availability there. And we combined the publishing and streaming components as a single point of contact for the client. So the publishing server requires IIS. So we decided to do streaming over HTTP IIS as well. So you can basically combine those roles and create this single instance component for the client. And in front of the streaming servers, we put load balancers to handle the load. So let me quickly run through some of the components that were part of this environment. So we have the database. It was already in place. They already had a clustered SQL solution, so we basically put the AppV database on top of that. We got some calculations from Microsoft, how to calculate the size. I don't know, as far as I know, it's not documented anywhere, but it makes perfectly sense because it's like the number of applications times the number of customizations that you build into that, plus the default customization that's always part of the package. That's basically how your database will grow. A challenge with this customer was that I think they had about 1,250 applications or something, and you basically wanted to rationalize that down to 250. We're still hoping that we can make that work, but otherwise the database will grow a little bit. And there are no alternate backup or restore procedures for the database. There's nothing specific there for AppV. So the management server, we created 2 separate management servers, one on each side. We didn't feel like high availability. That's a choice. It was basically based on cost. If the management server is down, we just recreate it, point it to the database, and it's up and running again. There's nothing, very hard to do in that environment. Not a very critical component in the environment. I mean, it is, but you can do without it for a couple of hours or something, I think. So we also didn't decide to back up that because the management server does not hold any information by itself. Basically, everything is part of the database, so it doesn't make sense to actually back up that environment. You could use like snapshot technology if you're using virtual machines in your infrastructure to quickly restore the information. Publishing server, we put 4 separate publishing servers. We combined it with the streaming server role, accessible through load balancing. We went for HTTP streaming only. Just like in AppV4, you have to do the content replication yourself. So you can either do robocopy or anything, or you could, like we did, leverage DFS or DFSR actually to replicate the content through the different streaming servers to make sure that all the information is stored on there. So for the load balancer, we had 3 primary goals. We wanted to give a good performance. So we want to optimize the server workload and make sure that the load is equally divided between them. We wanted to create scalability. As I said, we had no performance metrics whatsoever for this environment, so we have no idea how this environment would evolve. So we were thinking that it might be, it's very good possible that we had to add additional publishing/streaming service to the environment. And that's why we created the load balancer in front of it, so because it's much easier to build additional infrastructure after you've already put a load balancer in front of that. And also in regards to availability, we wanted to, if the server is unavailable, to be removed from the load balancer. So we used Cisco ACE for that. It was already present at the customer. We had an active-passive context. So basically, the active context lived in one load balancer on one side, and the passive context lived on the other load balancer on the other at the other side. So we configured probing, so we could easily, check out the HTTP ports that are part of that environment, which is by default 80 for streaming, and we used 81 for publishing, but that's actually configurable during the publishing server setup. And we have something called stickiness or device affinity, how Microsoft calls it, where you could say, what do you want if a subsequent, call from a client to a specific server? Do you want to redirect it to the same server or apply the load balancing rules again? And I think, from a performance perspective, you want to disable stickiness to just divide the load in every subsequent streaming request. So some of the other design decisions, we did not go for a reporting server. We had alternative solutions in place. In this case, actually, ZenWorks was able to pick up the exe files that are part of the AppV because it's now an open format, right? It's no longer a hidden or an inaccessible Q drive. So probably most of the solutions are able to pick up those applications from the client. We virtualized all the servers, basic specs. We felt to go more for a scale-out solution than a scale-up solution. I'd rather have more of the same, servers in the environment than creating excessive memory for them. And obviously the shared content store for VDI. All right. So our experience, how did this go? Let me start by running out. How many of you are using a user environment virtualization solution? Pardon me. Some of you. So this customer had Absence, which is one of the solutions that is out there. And basically, what it does when an application is launched, it can eject, the user configuration of that particular application and save it whenever changes are made to the user profile. So it's a profile solution as well as a user environment solution. And as I said, AppV5 was still very early. It was like beta 2 or something when we were running this. So we were talking to Absence how we should support this environment. But basically we had no issue. So their model of injecting their code into the executable at launch time basically worked out of the box for AppV5. So we did not have any any issues there. And that goes for both the personalization as well as the environment manager solution that they have. We did have some additional excludes because of the new folder locations that AppV is using. It was sometimes picking up too much information, so we excluded some information from the personalization server, and it basically, the profiles became more clean after that. And same goes for if you have application manager, which can disable access to applications that are unauthorized. You have to register the locations of AppV, obviously, to a whitelisted list to make sure that they can run from that location. So when it comes to sequencing, the process flow of sequencing is pretty much the same. There are no real different steps. There's one slight difference, is that the shortcuts and file types, we are used to doing that in the wizard in 4.6. It has now moved into the editor, so there's no question of which shortcuts and file types you want to be part of your package. You now have to move them. You have to do that at editor times. And the editor is a little bit different. There's one tab missing, and it sometimes holds some information that was valuable, like date times, and that's no longer available. But I wouldn't consider that to be very high impact. If you have AppV4 packages, and as I said, this customer was not an AppV4 customer, but they were already packaging actually for AppV4 because that was the way that they wanted to go before I joined the team. So they had about 50 applications already sequenced in AppV4, where we said, okay, basically we can migrate them to AppV5. Microsoft has a converter that is part of the sequencer installation, a PowerShell converter, that can actually migrate your AppV4 packages into the AppV5 file format. So the package model changes, so it could require some additional work. And as I said, the ones that we ran into, for example, is if you've implemented stuff at OSD level, at application level, you can only do that at package level. So it kind of depends how your current application estate, what that looks like, how much impact this is going to have. But as with any model, there's also some limitations. Let me quickly run through them. So the converter only handles AppV4.5 packages and higher. It does not have any 4.2 or 4.1 or 4.0 or how long you go back. So that those packages cannot be migrated. Also, if there's not an OS tag set to Win7 in your original applications, the converter will not migrate them. So these two are not even migrated. They are reported by the converter, so it actually tells you that it detected this, and you have to fix this before you can continue, but they are not migrated. So scripts from the OSD files, if you have any scripts, registry tags in the OSD files, dynamic suite composition in the OSD files is not migrated, but it does get detected. So you have a pretty good idea of the applications that might require some additional work. And this functionality is still available in the AppV5 customization file. So you can still add those to your environment, to your application package after it gets converted, because these are not blockers for the conversion process. It will just not migrate that piece of functionality. The next three are a little bit different because feature blocks are not migrated. I would say the impact is pretty low because it does not influence your application startup. I mean, maybe in a performance way, but it's not that the application won't start at all. Terminate children's settings that are part of your application package also don't get migrated. And if you have any empty directories, and I know the sequencer is not very likely to create this, but if you, for example, wanted to make the virtual directory win over some local directory, it was very common to add empty directories into your package to make sure that the localized don't conflict. Those are not migrated as well. These ones are a little bit tricky because, of course, they are not reported by the sequencer or by the converter. So these ones you actually have to check out yourself in your environment to see if you have applications that have these pieces of functionality. So the last ones are, they can be good, they can be bad. The new AppV extension points, which I talked about in the introduction, they are not created by the converter. Impact is low because the new extension points were not applied in your original environment anyway, but they don't get migrated to the new infrastructure. You can go to the sequencer, open up and save the package for the sequencer to apply those extension points to the environment, because they're probably part of the registry of your package, so it can pick them out and put them in the new AppV5 content. But that does require sequencing operations. Environment variables do get migrated, so that works, but I've run into issues where the environment variables were not picked up. I have that on a slide later on by the application. If you have any tokenized directories, the CSIDL, they get migrated to the new tokenized directories, the colon, I think, program file. I have an example later on. They do get migrated, but the same goes there. It does not always work. We have seen that it not always works. And it's also the same for if you have any references to Q. So if you have an application package that has a reference to Q in the registry, for example, the sequencer would have tokenized that setting, and the converter will put the new tokens in the new package. However, if that reference in the application package was part of a configuration file, for example, somewhere the sequencer would not put the tokens in, the converter will not pick those up. So you would still have a reference to Q in that application package. So these ones are pretty likely to fail because we don't have a Q drive anymore in AppV5. And there's actually a pretty easy way to determine if your application has any reference points to Q that are not tokenized, is by changing your drive letter on your client for a specific application. And like from Q to R or whatever you're using. And if the application would still run, then apparently so it either does not have any references to that folder, or all the references are tokenized. So an example of the environment variable, here we see a migrated package. We see the new tokens get applied. So we still have the path value. We have the new tokens. This was a specific application that created a subfolder in program files, common files. We can see that the program files, common files file is part of the application package, but the application couldn't find it. And we tried to fix this, and I don't know why the application couldn't find it, because everything seems to be running. The converter process was successful, but the application wouldn't work. So this one we had to resequence, actually. So another example here, msdir.cfg, a text-based configuration file for an application. It has a reference to Q, to the SFT MNT directory, and obviously these directories or these files don't get tokenized by the sequencer. And also, they are migrated by the converter, but the application will not work because on the client machine, it has no Q drive. So these are the ones you have to really look out for. I'm switching back to the demo, and that's a hint to the tech guy that this problem. Well, what do you know? So as I said, the converter is the converter is a PowerShell commandlet, and it's part of the sequencer installation. So you don't find it, it's not a separate installation, it's part of the sequencer installation. I have created a script. So basically the command is pretty straightforward. You can convert a legacy package from a destination path to from a source path to a destination path, and basically build through it. But I've created a script that simply enumerates through a directory structure, finds all the SPRJ files of the original application, and throws them through the converter, and parsing everything into a log file so that I actually can see what is going on. So let me show you how that works. I have about 4 applications, so this should be finished pretty quickly. The script, for the people who are interested, is part of my blog, so you can find it there, as well as some other scripts that I've written. I must say, I'm no PowerShell guru. Actually, I knew nothing about PowerShell because before Microsoft decided to put AppV, to make AppV primary manageable through PowerShell. So all the stuff that I've built is Googled or searched for on the web. So I'm not saying that it's perfect, but it might be a good start for you guys. So it has created these application packages, and it also created a log file. So I have an application 7-zip. Apparently, the converter detected that it had a registry variable part of the OSD file, and that the registry settings were found. These were the actual tags in the package, but they were not migrated to the new package. So if you want, most likely, I built this because the package actually needed it. So there's a good chance that the application might not work without its registry key. But it depends on how you are sequencing in your environment. How many of you are actually doing customizations with packages? Registry tag scripts, so quite a lot. So depending on how you are doing this and how often you apply that, this can be challenging. Now the good thing is the deployment and user configuration still holds the registry tag, so you can simply put it back in there and the application will most likely work. So FileZilla has a reference to an operating system that is not supported, WinXP in this case. So this package does not get migrated at all. And you can see that because my script created a folder, but the converter did not output the converted package. So to fix this package, I have to remove the OS tag from the application package for the converter to succeed. Quite simple, you can script that. And my best practice always has been to not put any OS tags in your application package. So it's part of the sequencer wizard now to not do that. And this is another example why that can be limiting to you in the future. And previously it was when you migrated from XP to Win7, you had to put them all through the sequencer. So application Chrome has a script. So it found this script tag in the package. Package did get converted, but the script is not part of the package. Scripts can also be added in the new deployment config files, but you have to do that yourself. And the last one, image burn, has a dependency, in this case to Chrome with this GUID. Now this is this makes sense because a dynamic suite composition cannot be migrated to the new package because connection groups are not part of the package anymore in FV5. So it's quite logical that the converter couldn't create those connection groups. So that basically shows you a little bit how the converter is handling stuff and is not handling stuff. So it's a good start, right? You should definitely, if you have an existing application estate, throw them through the converter, but be careful by looking at the packages, really test them to see if the converter either successfully converted them with errors or it hasn't mentioned anything and the application package might still have issues. Some of the other stuff that we are seeing, cross-platform. So one of the things my customers usually implement at V4 is to put packages both on x64 and x68, 86, sorry, Windows 7, Server 2008, throw it all around there and just with a single, sequence once, deploy many. That's the whole idea. There's a small change now in AppV5. If you have sequenced, so I have a 32-bit application. I can sequence a 32-bit application both on a 32-bit and a 64-bit sequencer. But if I've sequenced on a 64-bit sequencer, the 32-bit client will not accept the package. There's actually a check now in the client configuration that the package is not designed for the current platform architecture. So you are limited there. So if you are planning on migrating applications or using applications across different platforms, probably the most likely solution is to sequence on 32-bit. Now, I always have been a fan on sequencing on the platform that the application was developed on instead of sequencing on the platform where the client was running on. There's one small caveat, is that for some reason, if you've sequenced on 32-bit, if you deploy to a 64-bit client, the new extension points don't get registered. I think that's a bug. I don't know. There's no, I can't think of any explanation why that shouldn't work, but that's the only thing that I'm seeing now. And here you can actually see, this is part of the XML that is part of the package. You can see the actual sequencing station processor architecture gets captured. Unluckily, this is a file that is part of the appv package, which cannot be changed. Otherwise, you think, oh, well, just change it in Notepad and it will work. But you cannot change this file as it's part of the appv package. You can only change the appv package through the sequencer. But these are not configurable, unfortunately. So, the primary virtual application directory. I had an interesting discussion with somebody at the floor yesterday around this particular directory. So, in appv4 we had the sft mnt environment, or the variable, right? The asset directory where we install the application in. Best practice was to put as much of the files into the primary application directory, the sft directory, to keep the virtual file system as small as possible for performance reasons. Now, the performance reasons are arguable, as I've never seen them proven, and sometimes even it's inevitable to install something to the virtual file system. But let's not go into that discussion right now. So the same rules apply for appv5. It's now called the primary virtual application directory. Best practice is to put as much files into the primary virtual application directory, or PVAD, or VPAD, or I've seen multiple abbreviations for that, to keep the VFS as small as possible. But I've ran into a couple of gotchas. So first of all, the PVAD question in the sequencer is actually asked before you've installed the application. So it's asking you where is the application installing, where you didn't even have installed the application. Now, obviously, if you have a good packaging process and you've tested this installation out on a test machine and you know the actual installation directory and you created some proper documentation and give that out to the packager, or maybe do it yourself, you've investigated, this is probably not an issue. However, in real-world scenarios, under time pressure and et cetera, we find ourselves, sequencing applications and just, trying to do that as quick as possible. So the question is asked before the actual installation. So that raises the question, what should be the answer at that point? Can I do anything wrong there? Well, if you choose a directory in the sequencer that is not going to be the primary directory of the application, so for example, I'm installing Silverlight, and I think it's program file Silverlight, and it's Windows Silverlight, then everything will be part of the virtual file system anyway. So you cannot really, you cannot get it wrong, right? I mean, maybe not following best practices, but you cannot get it wrong. So the second thing is, the actual directory name is not even relevant because the sequencer will rename it to root after the application package is created. So in the end, so if I've installed into C program files Adobe, and I've put C program files Adobe as my primary virtual application directory, that reference is gone and will be root when the application package is created. So it's not even relevant. And the last one, and I think it's the most important one, is that the primary virtual application directory does not get merged if you are doing connection group. This is not an issue per se, but it really depends on how your application is handling the calls to the intercommunication of the application package. So some applications, look it up in the registry and can find the information, and some, are browsing directly hard-coded to a specific folder. So it really depends on the application if that last one is an issue. I've seen a blog by Microsoft where they mention that the fact that the PVAD is not merged, and basically you have to test it out in your environment to see if it works or if it doesn't. So if you run into a situation where two applications don't work after they have been created in a connection group, try to put everything into the virtual file system and see if the application is handled correctly then. Shared content store, I've talked about this a little bit. I think this is a real innovative and very, very good feature. I mean, specifically for VDI or hosted desktop solutions. It enables you to have a very lower storage impact. It's easily 80 to 95%. It really depends on the application package. It's easily implemented. It's basically a configuration that you can set on the client, and it works. It works out of the box. But you do have to remember that it creates a dependency in your network towards the streaming server. So the performance to the streaming server has to be good and has to be there in the first place. Another thing I've run into is something called the packet source route behavior. The packet source route is the replacement of what we call the application source route in AppV4. If you have multiple streaming servers and you want to and the OSD file will only hold, one streaming location, you could overrule that by the application source route in AppV4. And it's now called the packet source route in AppV5, but the idea is pretty much the same. And you can, set it in the client through group policy. Come to that a little later. However, if you have set a specific packet source route and you try to add an application from another location, the client will not accept that. So the packet source route now suddenly becomes your only, designated source for all your application packages. Is that a problem in production? Probably not. Is it a problem for troubleshooting? Probably is. Because if you are running on you're troubleshooting a specific application at a user station or something, you try to manually add that package to the client, or troubleshooting in any other way, you are getting denied. And that goes even. The only thing you can do to eliminate that location, to overrule that location, is by a product source URL opt-out, which is part of those configuration files. You can put another folder in there and you can overrule the packet source route. The problem is, what would be the scenario? I'm troubleshooting a certain package. I don't want the production streaming server to be my designated source. I want another one. I put it in the package. I test it. It works. I have to change the package again. I have to get that opt-out out of the package again before I can set it to production. So it's a kind of I don't see a real good, actual implementation for that. But it's important to know that the packet source behavior is different. So the question is, do load balancers change this? No, the load balancers do not change this. What would be the case if you set the client to a specific load balancer virtual IP address? The load balancer obviously replaces the communication, behind the load balancer. But for the client, it's still a one-stop shop. Yeah. And an important one is, and that's also different in AppV4, is that the packet source route does not get applied to any active sessions. So it was the case in AppV4. If you would apply it, you could immediately see that the client picked it up. There are certain timeouts that have to occur for any active sessions to change to the new packet source route. If you add new packages or anything, then obviously the new packet source would get applied immediately. But for any active sessions, it might take time. And that brings me to how do you set all this stuff? Well, luckily, Microsoft has delivered a group policy template. And most of this, the settings that we've talked about, shared content store, the streaming server, the packet source route, and those kind of things can be set by the group policy. But, and this is both a good and a bad thing, if I've set something, packet source route, through group policy, I can see that now on the client, and the client actually takes that as highest in the hierarchy. So it respects that at all times. So there's no way to change that at client level anymore. And again, for troubleshooting, that might be a little challenging. So in the case of the packet source route, if the packet source route was set through group policy, and I wanted to change that on the client for testing purposes, I'm not allowed to do so by the AppV client. So make sure that the settings that are, or might, you might want to overrule maybe sometimes on the client, they don't flow down through the group policy, because AppV will respect that at all times. So looking at the management server and the publishing server, I think it's good that they split that up. It creates a more robust and scalable environment. The setup is fairly easy. You can use DFSR for content replication. So this is a pretty good implementation. What I did find out is that the publishing performance is no longer linear. So in AppV4, if I have more packages, the publishing time or the refresh time will take longer. I found out here, for example, I have here a graph where I have 10 applications of 200 megabytes and 10 applications of 6 megabytes. The last one takes longer to actually apply to the client. So it's no longer linear. Now this does not, by definition, mean that it has something to do with the packet size. That's only my personal observation. I know that Microsoft, I've been working with them on this case. It also has to do with the number of extension points that is part of the package. Obviously, if your package, for example, COM, that's an application that is very COM intensive, has a lot of registration to do at publishing time. So the application gets added, and all the OS integration points have to be registered as well. So that may take some additional times. So that's an explanation as well. But the important thing is that it's no longer linear. So if you are doing refreshing from the publishing server, make sure that you test those scenarios out with your specific use cases for your users. And also, during that publishing refresh, the start menu flickers. So each and every application that gets added is a refresh of the start menu. And it might be, we found out that it's quite annoying for non-persistent VDI users because they log on. This process kicks in, and they, for example, want to start Outlook, which is just part of the image, and they browse into the start menu, and halfway through, the start menu flicks down again because an application is published on the background. And then they try it again, and it flicks down again. So that's quite annoying, and they have to wait until the whole publishing refresh process is finished. But there's no progress for that. So that was quite an annoying one. So we are still testing our environment with a product called Login VSI. How many of you are aware of this solution? Some of you. So Login VSI is a performance and benchmarking solution for hosted desktop environments. And it basically can generate workloads on your environment. So we are currently stressing out this environment, putting a maximum amount of users on our VDI environment to see how the streaming servers are holding, how the database is holding, and those kind of things. There's somebody from VSI in the room. Back, you can see it by his logo. If you have any interest in this product or get a free license, be sure to ask this guy to work with you. So rounding it up, key takeaways. I would say that AppV5 is a pretty solid release, future-ready release. SP1 is already out, and I know that for a lot of you that's kind of a milestone because we're not looking at it before SP1 gets out or gets into the product. So it's out there, so there's no excuse for you to look at it. It has a rich feature set, but I do have to admit that there are some changes, and not everything that we are used to is part of the product anymore. And that's not per se negative, but it has changes. But if you want to, build a new good foundation for a future-ready solution, you have to, make changes to the product. So I would say that the impact is the biggest if you're an existing customer and you have to go through the migration process and the package conversion process. So that's look into that as well. So and if you're not an existing customer, I would definitely say go for AppV5. If you're interested, me and 3 other MVPs are writing an AppV5 book. We have Chapter 1 available as a free download. We are working on on Chapter 2. If you are interested, either visit the website or give your email address to me. I will be sure to hook you up with an edition. And with that, I'd like to thank you for your attention. And I think I have still some room for questions. Questions? You can stand up to the mic or... Nobody? Really? Oh, there's a question.
Hey, I was wondering if group policy passes through the virtual environment for virtual applications, such as like Office. If you have group policy settings for Office and you virtualize Office, do those settings pass through the virtual environment? That's
actually a very good question. So the question is, do group policy settings flow through to the virtual environment? And I didn't mention that in my presentation, but there's actually a registry key, now part of the AppV client implementation, that where you can put the registry keys that are independent. If they are part of your application package, the AppV client will ignore them and will flow down to the, or will respect the local settings. And HKey local machine software policy is by default part of that implementation. Yeah. Next question.
Have you done any implementation of AppV with SCCM 2012 and utilizing SCCM 12 infrastructure rather than the AppV infrastructure?
I have not in a production environment, but I do have implemented that to see how the integration is working there. Yeah. Any particular question you had in mind?
Yeah, so what are the challenges? Is it feature parity from both infrastructures, or do you lose some features, like feature block and some of the streaming aspects to it? Because from my understanding, it's SCCM 2012 is delivering the package, and it delivers it locally, and then the AppV client hands it off.
Okay, so no, the feature parity with SCCM, I think both the infrastructures are coming together quite close at this moment. You do require SCCM 2012 SP1 to integrate with AppV5. I think if you already have SCCM, and I think if I remember the hands, most of you have, I think the good thing is if you have SCCM, you have a migration path towards at AppV5, because SCCM 2012 SP1 can deliver both 4 and 5 applications, so you can determine your own pace in your migration. One of the benefits now of SCCM SP1 is that the connection group management is now also part of the infrastructure, which was a downside in previous releases, obviously, through DSC limitations. So I think they are coming really close together. Streaming is also possible. You can, if you're doing RDS scenario, you can preload the applications into the cache. Streaming goes straight into the AppV cache, does not get stuck in the SCCM cache, which was a challenge in 2007. So there are definitely some benefits for SCCM, definitely. A question here in the front?
How many packages do your customers usually have on a scale of 50, 250?
Okay, so the question is, how many packages do my typically my customers have? That depends. That depends on the customer. So I think this customer that I'm talking about, they will end up probably between 250, 300 applications, because having like 1,200 applications on I think 4,000 users is quite a lot. Governmental companies do tend to have a little bit more applications than others, but there's no real standard number or something that I can mention.
And can you have it too much? Would you recommend doing IE plugins as well?
Yeah, so the question is, do you recommend or can you AppV too much? That really depends also on the organization. So IE is a good example. IE, I think having plugins in IE, it also depends how the user is experiencing it. I can probably tell I know from the majority of my customers, the users are very tied to having, I always use this shortcut because that one works, and if you can tell them to use that specific one, give it a descriptive name, it can work for IE and plugins. For example, if you use Office and plugins, it can be challenging because then you have, if you do Excel with this specific application, then you use this shortcut of Excel, and you have Excel with this application, you have this shortcut of Excel. That's probably something users will not understand. So it depends on the user experience and I think it also depends on the application update life cycle. If you either virtualize them, put them in the same bubble, put them in connection groups, the number of updates that you're going to get. So for example, if you have an application that has a very old version of Java, and it's not going to change because a new version doesn't work with the application, why would I bother building a connection group, for example, and just put it together, create a single entity, and push it out to the users? While if I have, for example, Oracle client, that has a very strict update cycle, very specific version that has to be applied, for example, that's probably better off in a separate connection, in a separate AppV package, and create connection groups to manage those. So, yeah, it's more of a strategy that you have to create in your environment. So. Okay. Questions in the back?
A question about the shared content store and the performance of it. Do you have any insight on the scalability of the shared content store? How many VDIs per streaming server that you need, or
So I don't have those kind of metrics yet. I haven't seen those kind of metrics yet public anywhere, and that's also the challenge that I had with this customer. So my advice would be to, if you're building this environment, try to build it as scalable as you can possibly can. So building it, like creating those load balancers, making sure that if you are hitting a performance limit that you can extend. The numbers that we currently have is what I said, it's like 4,000 or it's probably 3,000 concurrent or something on 4 streaming/publishing servers. And we're doing, actually I started doing load testing there last week, so we are building those numbers as we speak.
So what kind of like network pipes do you have on your streaming servers? Are they 1 gig? Are they 10 gig? Or
I think the streaming servers, I don't know out of the top of my head, I think there are 1 gig connections, yeah.
are they sitting like in the cluster, in the same cluster as the clients in
Yeah,
ESX?
no, not in the same, in the same cluster, but they are part of the data center network.
Okay,
So one of the
going through
alternatives,
the load balancer anyway, right? So
yeah, true. So one of the alternatives that we also investigated, and is actually a pretty good solution, I think, as well, if you look at it, but it kind of depends on your infrastructure. You can also make the streaming server, for example, part of your chassis or your blade infrastructure,
Right.
making sure that the VDIs that run on a specific
never goes out of the
never goes out of that. That would be a solution as well. But you probably create some overhead when it comes to package content, because for every blade, then you have to put the package content on that stream. But that's an alternative solution you can apply as well.
And just one more, they, the choice of using HTTP versus, say SMB, was there any kind of performance?
Measurement?
Yeah, measurement on that, or?
No, we did not do any performance measurement. We basically chose for HTTP because, as I said, IIS was already part of the solution. And I personally think that HTTP is a more scalable and faster solution. You could question that with SMB3, of course, but I have no performance metrics for that whatsoever. So hoping that Microsoft will deliver those soon.
Thank you.
You're welcome. Go right ahead.
Hi. I have an infrastructure question. Our environment currently is AppV 452, and we are in a dilemma. Should we go to AppV 4.6 SP2 on the back end, or should we go to AppV version 5? And also, would AppV version 5 run on Windows 2008 R2, or does it require Windows Server 2012? If you could give us some recommendations.
Okay, so the question is, so your current environment is AppV 4.5.2, and you're wondering how and what versions are supported on the new platform?
That is correct.
So the server components are 4.5.2 is, I think, the latest release, actually. So the server components probably won't change. The migration path, if you have a full infrastructure, is that you have to build a separate AppV5 infrastructure. On the client, you require 4.6 SP2 as a minimum if you are doing a side-by-side scenario on a single client. So you have to upgrade those to SP2. And they're supported both on Windows 7 and 2008 R2 as a minimum and up. So those are, I think, pretty much the configurations that you have.
Our clients are already at AppV 4.6 SP2. Our AppV server backend is actually Windows 2003. That's why I was asking if we could go to Windows to Server 2012 directly, or if we want to stay on AppV 4.6 SP2, just looking for an appropriate migration path.
Yeah. So the infrastructure, if you cannot upgrade the 4 infrastructure to 5, so you have to build that one separately anyway. And if you're building that and your default platform is Server 2012 at this moment, I would definitely put that on 2012 and then migrate those packages over. Yeah.
Thank you.
Okay, you're welcome. We're running out of time. I'm at the Ask the Experts tonight. If you want to see me, talk to me, have any additional questions, thank you for your attention. Oh, and be sure to fill out the evals for the session.